what are the, like, let's first write down like the possibilities. So we could do like clues we could give. So you could have, like there's, just like it is with the rods, you can do twin numbers, right here. Twin numbers, triplet numbers. What else?
Can you stretch your paper so it's larger?
I can. You can't see it? Do I need to make it so that you can like this way?
Yeah, that's good,
Okay. So twin numbers, triplet numbers. We could say one number is a third, a quarter, or a half, or something like that of another number, of another digit. So I'm going to get rid of numbers up here and put digits. So there's twin digits, triple digits, what other clues can we give?
Yeah, we have never tried this. We just did the random numbers, whatever, or sometimes like we just pick up either Bible or dictionary and to see who gets a bigger number.
Okay, so if we could do quarters, so if we could do fractions, can we also do twice as big or 3 times as big? So you have one digit that's twice as big as another, or 3 times as large as a number. Yes, no, you guys like that clue? 2 times or 3 times another digit. Our digits could be odd. What else?
Even.
Even or both.
A zero. But there's no zero, right? That should not be zero.
Odd, even, or both. Or it could be a 3-digit number, and one is odd and one is even. And then you have one that's neither.
Which one is neither or odd, neither even?
0 is neither nor. So if you had like 1 and 1, 0, and a 3, you would have 2 odds. You have 3 digits, 2 are odd, and 1 is neither.
Okay, but a digit sum could never be a 0, right?
Well, a digit sum might be 0.
Unless you allow the negative number. Because when you hit 10, it turns to be 1.
So, well, no, we talked about this. So let's look at, because I have these up. So I have these. So I have a 9-point circle here, right? 1. I just want to make sure I do. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we put 9 at the top, 9, and this is then 1. I don't know if you guys can see that very well. I'll make it bigger. Then, oh, let's undo that. Okay, 9, 1, 2, 3. I'm not going to label all these because we're going to do this later. So this is 7. This is 8. This is 9. And this is going to be 10. This will be 11. So when we turn around and come back up here, this one is going to be 11, 12, 13, 14, 15, 16, 17, 18. So 1 and 8 is going to end up here. 18. 18. So what if I added a 9 and a 9? And what could I add so that we had, so we have 2 9s, so it's 18 and a 1. So what's the digit sum there going to be?
So, excuse me, I missed that. So, 9 plus 9 plus 1?
Yep.
Okay.
Oh, that's got a digit sum of 1. So where are you going to get a digit sum? So let's figure out when you're going to get a digit sum. Let's say we're adding 2 numbers or subtracting in both of our digits. So how about we do this? We have a number with a digit sum of 6 and a number with that's where you're going to see it, because I'm trying to figure out when I would see this, a digit sum of 0, but we did it last time and we got a digit sum of 0. And we have, let's say, we would have to create this. I can't type. It's not typing for me. 6, 51 minus 15. So let's figure that out.
It's 8.
8. So let's actually figure it out. This would be what? This would be 6.
That's no, it's a 6. Yeah, 36. 9.
Why? Oh, I see what I'm doing. Delete. Right. So we have 36. 36. But the digit sum over here, so it's going to be a digit sum of 9. So over here, we're going to have a digit sum of 6. And we're also going to have a digit sum of 6 here. And when we subtract these two, because it's a subtraction problem, what are we going to get? A digit sum of what will our digit sum be? And then what happened? Nolan, can you tell me what happened? That's not supposed to be how it works, because we got a digit sum of 9 and a digit sum of 0.
I did not get it, so you have to explain to me.
Okay, so we can use digit sums to correct our work.
I don't understand what you're doing either.
Well, we have a digit sum of 6 here. 51 has a digit sum of 6. 15 has a digit sum of 6.
Okay.
We can subtract these two digit sums and get 0.
Okay.
Right? And then so that the digit sum going down should be the same as the digit sum, or digit sum across should be the same as the digit sum going down. But over here we have a digit sum of 9.
Which is 0.
And a digit sum of 0. And the question is, so right, so Nolan, can you explain to them why 9 is 0?
Well, like what you showed us on Monday, how the 0 goes right below the 9.
So yeah, so 9 and 0 are the same.
Yeah, so I think I read your post about 9 and 0 same before, but I did not get it. That's why I think.
Yeah, so you start here, and anything as you go, everything on this arm here is going to have a digit sum of 1. Anything here is going to have a digit sum of 2, 3, and when it comes back, we start here at 0, because it has to go somewhere. So the digit sum here will have to be 0. So 0 and 9 are the same. So you wouldn't get a digit sum by adding them together. I was trying to figure that out. I was like, well, it's never going to happen. But by subtraction, you will get a digit sum of 0. All right, so let's go back to here. So let's pick a random number and write a digit sum puzzle for it. So let's pick out a random number. Oh, we can also in our clues write it has the digit sum, obviously. Okay. So throw out a number, a random number. Frankie.
我就吧，就行了。
Yeah.
9.
No. Two digits numbers, all right?
Yeah, just pick one, and then Nolan can pick a number. We're just going to randomly pick a number. So Nolan, you pick the next digit.
8.
All right, Frankie, the next one.
Any number.
3.
Okay, look at that. So let's write a digit sum puzzle for this particular number.
9, 8, 3.
Now, we don't have to stick to these, but let's just start with, like, what is the digit sum? So we have a 3-digit number
Okay.
with a digit sum of what?
就是9加8，就是让想想
17.
17。
What's the digit sum, Nolan?
I know.
Let Nolan say.
Okay, so 2.
Yeah.
All right. What other clues could we give about this?
It's a multiple of 2. I don't know.
So you could do 1 digit is a multiple of 2.
I don't know.
Okay, I like that. What else could we say about that? Instead of saying it's a multiple of 2, we could say 1 digit is even, right?
2 digits are odd.
2 digits are odd.
Mama.
So what else could we talk about? Because, like, I bet there's more than one way to solve it as it sits. Because we could do 7 and 5, I think. 7, 5, and 8 would still give us the same.
And it's not prime number.
它上面有这些 clue.
So we need one more clue.
你可以试一下。还有 clue.
So we could do the difference between the largest.
One digit is a third of the other one.
Between the largest and small. Oh, so the smallest digit
It's a
is
third of the
1/3 of the largest digit. Okay.
So do we have to follow the 6 rules that you listed, or can we create?
No, you come up with anything you want. I'm just giving ideas for clues.
Okay.
Yay.
Okay.
Okay.
So what is this? What is this a lot like? Nolan probably hasn't played the game, but you have, Frankie. So what is this a lot like?
Substitution game.
Well, yeah,
Okay.
or the guess my rod or guess my train.
Uh-huh.
Yeah, kind of.
I would say I add another clue. Square root of the largest one.
Okay.
The difference of the square root of the largest one And the cube root of the second largest one is 1.
Oh, so hold on.
Oh, there, I fixed it.
Oh, well, let me just put it back.
Let's see.
So the square root
Or show the square root.
of the second largest one
No, of the largest one.
and the cubed root
It needs sound. Needs to be.
可以啊。I mean the difference between.
yeah.
I have one. The smallest number multiplied by the big largest number is the smallest number cubed.
Digit mu.
Like this. This
Oh,
one.
look at that.
Oh,
So let's pick another one. Because this is basically the same as, yeah, guess my train, only we have added
I have another one.
another clue.
Yeah.
Okay.
The largest number is the smallest number squared.
Okay, the lar. That one will be, if everyone knows it's odd, that's a dead giveaway. Because there isn't, because there's even numbers, so that would be the only, if it's odd, that's the only one that really works. Okay, let's pick another RAM number. 3 or 4 digit number, doesn't matter.
I like this game. It's trying to see the patterns, the relationship.
Uh-huh.
I have one.
No, let Miss Sonia. She's going to come up. Let's come up with different number.
I
Great.
have each number.
Oh, just 1 digit each time.
Oh man.
Well, just throw out some digits, and then Nolan can pick
3.
the next digit.
Nolan said 3.
Can't pick a one that's more than 1 digit.
Do you want one that's more than 1 digit, or do you want to give more than 1 digit? Is that what you want to do?
Which are the B? I want one that's more than 1 digit.
Oh no, Nolan just come up with 1, and then you can add 1. That's more than 1 digit.
Give me more than 1 digit. I don't care. Give me lots of digits.
1. Come up with 1, Frank.
83, 25, 67.
And 78.
Okay, so 7, 8, but what did you say before that?
1,258.
Can I leave the 3 there?
Yeah, sure.
Okay. All right, let's come up with our clues.
可以的，就用这个，这个数字填大填。
I think it's more complicated if there's more numbers. And buddy, stop finding the end of the stick.
It is more complicated the more numbers you have. That's why I like trains that are like 7 or 8 long, and you do the guess my train things. I like that when there's like 5 or 6 rods in your train.
Okay, I think I've got one.
Okay.
He
the I don't know how to say this.
Okay, well, I'm going to start out with the most obvious. It's 5 digits. Digit sum is,
3 digits are arranged in staircase.
1.
digit
Yeah,
sum is
1.
1.
Digit sum is 1.
It's 4 plus 2 plus 8 plus 5.
What?
So it's let me see, 10
1.
plus 9, which equals
19.
10, which equals 10, which equals 1.
So you agree the digit sum is 1. Okay.
How about let's just
Okay,
say
so the
sum used to be considered a prime number.
I don't think 1 is a prime number.
Yeah, it used to be considered as a prime number.
Oh, used to.
okay, so I'm trying to figure out how to say the 1 and the 2 equal the largest number.
And I have
The 1 and the 2 equal the largest number.
Yeah.
Yeah, I'm not sure what you mean by that, because 1 and 2 is 3, and the largest digit is 8.
Or you want to say the 1 and 2 equals to the first digit?
Yeah.
Okay. So you would say the second 2 digits equal the first digit.
最大。那你还可以说
Yeah.
Okay.
第二大、第三大的和第四大的相当于最大的加起来。
The second digit cubed, the third digit cubed equals the largest digit.
I was just going to do that. So, third
Digit cubed
equals,
你可以找
Oh, I have one.
Mhm.
The largest digit divided by the second smallest, which is the 2. Minus 1 equals the first digit.
Why don't you say minus the second digit? How's that?
Yeah, my second digit equals the first digit.
so the largest digit divided by the second digit, or
The second smallest. Or the third digit.
okay, so let's do that. The largest digit divided by the third digit equals smallest digit.
No,
Yeah.
minus the second digit, or the smallest digit, subtracted by the smallest digit. 不是4减1这个。
Oh, minus 1, third digit minus 1.
Or the smallest digit.
So the largest digit, so let's just read this. So the largest digit divided by the third digit
Which is 2.
minus 1
No, he's meant to say minus the smallest digit equals to the second digit.
No,
Is that right?
equals to the first
Oh, equals to.
digit.
Okay, let's see. I'm
Hey.
sorry.
equals.
To the first digit.
How about that one?
Not the equals to this the first. Oh, yours is
or the third. Mama, why can't you?
no. That's that one.
8 divided by 2 minus a small 1 equals 1.
Mhm. Yeah, he meant to say minus equals to the first digit.
Okay, what it says is 8 divided by 2.
Minus 1 equals 1.
No, because 8 divided by
No.
2 equals 4 minus 1 equals 3.
Yeah, he said
The
equals
first digit.
equals to the first digit.
Yeah.
Okay, it took a long time to type that.
No, not type. It took a long time for us to organize ourselves.
I already got mine organized. But
Now,
Oh,
this
I have one. The fourth digit plus the first digit
Equals to the last.
equals the largest digit.
now somewhere in here we have to let them know that what is going to be like where the digits are, because it's possible we could have a train, but our train isn't in the right order.
Okay, I see.
Do you see what I mean? Like we have this one up here, but I don't think we actually have enough clues because I don't think we can tell what order they're in.
Okay, now I kind of know what we're doing now. Okay, I have one. The first digit plus the second digit multiplied by the third digit equals to the last digit
First digit
plus second
plus times third.
Yeah, there need to be a bracket of between the
Equals
first.
last digit. Okay.
There needs a bracket for this. Or I say the sum of the first digit and the second digit. Okay.
Do you want sum? We can do that. Sum
Oh.
of, and then
So-
I'll get rid of this.
Yes.
Because I like them in statements rather than,
Equation.
okay. So the digit sum is 1. It's 5 digits. Second 2 digits equal the first digit. So the third digit cubed equals the largest digit. The largest digit divided by the third digit equals minus the smallest digit equals the first digit. Are there enough clues here to figure out what this is?
Wait, I have one.
Okay.
So the first digit plus the second digit
So first digit plus
squared equals equals the last digit times the third digit.
That's a pretty good one.
First-
Now, what are we going to do for that 5? I don't think we have any clues for that 5.
I did one with the 5.
That is true.
The largest number subtracted by the first number equals the fourth digit. The largest digit subtracted by the first digit.
So the last digit minus first digit equals fourth digit. Do you think that's enough to figure it out?
I don't know.
Maybe.
I think we've got enough.
Well, I think we leave these and we post them in the group and find out who figures them out.
Okay.
Oh, wait, I have one. I have one last one. The first digit plus the third digit equals the fourth digit.
I think we already have that one, right? No.
Now we have last digit minus the first digit equals the fourth digit. And now we have the first digit plus the third digit equals the fourth digit. This is going to limit a lot of what it could possibly be.
The first digit plus the second digit plus the third digit equals the last digit minus the third digit.
Okay, first digit plus second digit plus third digit
Equals to
minus, equals last digit minus
minus what?
The
third digit.
Wait, I just found another one.
Okay.
Okay, so the first digit plus, well, no, wait, hold on. Let me flip.
I'll go up so you can see it. But I'm going to go down. I'm going to shrink this just a little so I can type.
I have one, the second, the third, the fourth, together equal to the fifth.
No.
Who's that?
Just kidding. Yeah.
So back to Nolan. First digit plus.
Okay, okay, can you go up a second?
I'll just write the number down. It's 31258.
Oh, hold on. Yeah, I can. There you go.
Okay, you can go back down. I have it written down.
Okay.
Okay, so the first digit plus the second digit plus the third digit plus the fourth digit minus the first digit equal the last digit.
So it kind of is like this one, except for we added one and took it away. Those are Philip's favorite kind of, his favorite kind, adding and subtracting the same number.
Let's look
I
at
have
Nolan's.
one.
Let's look at Nolan's because the first is
Second.
3, 1, 2, and 5. 3, 1.
The first
No, hold on. Let's
Plus
check
the
that. Make sure because
second-
we're going to post this one. I want to make sure I got it right. So
the
3.
first plus the second plus
I think it should be -2. Oh, minus the first. Minus the first. Okay.
I have one.
Okay.
I'm running out of room.
The
I can keep
first
going.
of the
Okay, maybe you should write the number down again.
The second digit plus the second digit plus the third digit squared. And no brackets. Squared only the third digit. Equals the fourth digit.
Okay. Okay. So the second digit plus the third squared equals the fourth.
I think there's a one might be helpful because since we already have one about the first, the one is that the third, the second plus the third squared. Okay, I need to. No, okay, forget about that one.
It was up here, somewhere up here.
Yeah.
Yeah, the difference between the square root of the largest digit and the cubed root of the second largest digit is 1. The largest digit is the square of the smallest digit. Yeah, we had that one. All right.
Okay, I give out one. I don't know the second smallest is twice as big as the smallest.
Okay.
So almost we should have enough clues there now.
The second smallest digit is twice. Yeah, I think that's a lot of clues.
Yes.
I have just one more.
How about we go to another number? Let's just do another random number.
Wait, just one more.
Okay, go ahead.
Okay, so the first digit plus the second digit plus the third digit.
Okay, first digit plus second plus third.
Yeah. Minus the fourth digit equals the second digit.
Hold on. Equals the second digit.
Yeah, I think we've got enough hints there for that one.
You know what? I'm going to take it and post it right now in Facebook, and we'll see if anybody solves it. How about that? By the time I'm done.
Who knows if anybody will?
There might be somebody who does. Nobody, so let's go over here to homeschool math. Let's do, we are in class right now. We have a for you. There we go.
Okay.
All right. So let's go back here. All right.
That's a lot of stuff.
All right, let's pick another random number. So these are fun just to post in this Facebook group and see who gets them. So we usually do them by Guess My Rod, but the older kids can certainly do the Guess My Digit, and especially it gets really fun if we can do digit sums in there. So you are welcome to post your puzzles anytime in the group. All right, so let's pick another random number. I can just type.
58, 30, blah, 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 blah.
I did this. I just randomly typed. I can randomly type again if you don't like that number.
We should like any number.
How did you get Y though?
Because I just touched my fingers on the top, on the where the numbers are, and I accidentally hit a Y. Do we want one that long, or do we want it shorter?
Let's make it shorter.
No, longer. We should put.
Like that?
No. Oh gosh, no.
Oh,
No.
Yeah, it gets harder to figure out.
it could be everything.
Yeah, let's just try this 4 digits. I think we now I kind of know more about the rules. Let's work out this
No,
one.
add a 0 behind it.
Add a 0. Okay.
Oh
so
gosh.
5 digits. 5 digits. Digit sum is
All the digits times the first, second, third, and fourth digits multiplied by the last digit equals the last digit.
okay. So that's actually a good clue. So what is it? The first 5 digits.
But it could be 1 or a 0. So
You said the first
4.
part.
The digit sum is 4.
All right. Hold on. I will get back here. So what? So the first 4 digits, or do you want to do the first all the digits multiplied by the last one?
So now we have clue for the last one.
Well, it can't be 1. It can't be 1 if all of the other digits are,
Okay.
because that would, if you multiplied, if it was 1, it would be all the other, it would still be 1984. Because it's still 1. So if you do the last one, the first 4 times the last digit equals the last digit. So that tells you for sure that it's a 0.
Okay, I have one.
Okay.
So the first digit Wait, hold on. I forgot what I was going to do. Let me think about it.
I have one.
Okay.
All the digits plus added together equals the first 4 digits.
Okay, what?
All the digits added together equals
The digit sum of the.
digit sum of the first 4 digits.
Okay. That's another clue that your last digit is 0. That's pretty good.
The third digit equals the last digit times 2. Or 2 of the last digit, or the third digit equals the fourth digit plus the fourth digit.
Is that good?
Yeah. And the second digit is the largest digit. And the first digit is the smallest digit. Not the smallest digit, the second smallest digit.
Okay, mine was the first digit plus the third digit equals the second digit. No, first digit plus third digit. Equals the second digit.
I have one.
Hold on. I have one.
I'm pretty sure you found out mine.
Okay, go ahead. You do it.
Oh no, you didn't. The digit sum of the second and fourth equals the fourth number. Fourth digit.
The digit sum of the second, or the first and the fourth?
No, the second and the fourth.
Oh, okay. Well, hold on. So the digit sum of the first digit.
No, the second.
Hold on. Let me finish mine.
Four.
Equals the. And so you have the digit sum of the first and
No, the second.
of the.
Second
And
And-
fourth.
is the fourth number. Fourth digit.
So you could do the same thing, because you can do the same thing if you add the second and third. It is the digit sum of the third. The digit sum of the third number is equal to the digit sum of the second and the third.
And the digit sum of the second and the first is the first digit.
Yep, that's what I did that one here. So you can add 9 to any of those numbers and the digit sum stays the same.
I have one.
So hold on, do you want me to do that one for the second and third? Or just leave it at it as it is? Okay, your turn, Nolan.
The last digit is the smallest digit.
they can get it? You should be able to figure out the 9. You should be able to figure out the 0. And we have something here that says the 1. We would know for sure that the first digit is 1.
The first digit multiplied by the second digit equals the second digit.
So that should tell you that this is a 1. We should know that this is a 0. We should know that this one is a 9. And then we have this is twice this one. And so is it going to work out if it is a 2 and 4? Will the digit sum still be the same? So you would have 3 and so you would have 2 and 4, 4 and 8, 3 and 6. So that's it. 2, 3, and 4 are the only option.
Wait, I have one. So not 9, the second digit plus the third digit equals the fourth digit squared plus the first digit.
Okay, now start again.
Okay, so the second digit plus the third digit equals the fourth digit squared plus the first digit. Plus the last digit.
Okay. Well, that solves whatever issues that this would cause. So I think there are enough there to find our number. Should we post it?
Yeah.
I guess.
Okay. All right. So I want to show you guys something before, here we go. So these are fun and I'm going to email them out, but you have them if you have the digit sum pack. You have some of them, but I made all of them. I think there's multiple pages here. I didn't make all of them, I made a lot of them. So let me see how many pages we have. Just a second. I have 9 pages, and just 2 seconds, Anna. Well, not 2 seconds, but not too long. All right, so we're gonna do some circle point multiplication. So, or some circle multiplication, and so let's just show you how this works. I'm gonna start at 0. We're gonna multiply, or we're gonna do here. We're gonna do difference of 2. We start at 1. And then we're going to multiply 1 times 2. is 2. We're going to do our multiplication. What is the next one? 4.
Then
Next one is 6. Next one is 8. And then we're back over here to 10, right? It's going to put you back on the 1. 1 and 0 is going to give you 10. Should be here. Sorry, I should be here. Oh, no, but I think that's right. So let's do 3. Actually, it should start at 0. So hold on. And then, so it's 10. And then we have, hold on, 12, 14, 16, and 18. There, now we have our pattern. So we're going to start at 0, and we're going to do our multiplication tables on there. So let's do, you guys can come in here if you want. So let's start at 0, and we're going to do our third. So we're going to do times 3. So we start at 0, 3, 6,
9.
9. And then you would
12.
do your 4s. Obviously, you can do the 1s, and what are you going to get? Just a little line all the way around the outside. So we could do times 4. So 4, 8. I'm just going to count 12, right? 1 and 2. 12,
16.
18. Wait, 16 is 7. 18 is 16, 20. 24. So it's going to be a 6. Oh, so you get it. So you can see the patterns that develop in here when you do this. So they get really interesting when, not here, but when you do them on like these. When there's a lot more numbers, the patterns get more and more interesting. So you'll want to start and then start with this, not the one at the top, but the next one, and just number these all the way around and do your multiplication tables all the way around and see what patterns you come up with. So it's a lot like string art, if you've ever done the string art.
Hey,